Lesson 2-3, Extrema and End Behavior. Looking at all of this graph together, and instruction tell us that to describe the end behavior of each linear or non-linear functions. Okay, let's begin from this section. Right, now this is the positive side of x and negative side of x, positive side of y and negative side of y. Now let's start from this one. So end behavior of this section, as x approaches positive, this is positive infinity, then f of x approaches negative infinity. So this direction, see, as it goes to the positive, then the f function going down to the negative. And for this end section, as x approaches negative infinity, then f of x, so when you go to this side, this is a negative for x and the positive side for function f, so to positive infinity. For this section, as x equals, well, not x, sorry, as x approaches this side first, as x approaches sorry, this is the line, as x approaches positive infinity, f of x approaches, sorry, this is not approaching, f of x equal to, is equal -2. Okay, so from this side, how about this side? This side is the negative side. As x approaches negative infinity, f of x stay the same, which is -2. Number 3, begin from this side first. X approaches to this side positive infinity, then f of x approaches also positive. And then for this direction, as x approaches on this side negative, it goes to the negative side, negative infinity, then f of x approaches also negative infinity. Number 4, this side first, this positive side, so as x approaches positive infinity, then f of x approaches this side down here for the y, a negative infinity. For this side, as x approaches this side in negative infinity, then f of x approaches negative infinity, going down. This graph begin from here. As x approaches positive infinity, then f of x approaches, this is positive. And then this side, as x approaches negative infinity, then f of x approaches, this is the negative side for x, and for function f is still positive. The last one begin from here, this positive side, so as x approaches positive infinity, this is a positive, then f of x approaches also positive. On this side, as x approaches this direction, is negative, and then f of x approaches negative also. Okay, that is all for lesson. This is lesson 2-3. Now let's continue to 2-5. Where we skip 2-4 when we continue to 2-5. Graphing special function. Okay, now we call this as piecewise function. And we have another graph called the step function. We'll do that one later, but we work on this number first. Right, now to graph this function, actually you have three lines together. You have one graph of 3 minus 3x given this domain, and one graph f equal to x given this domain, and another graph equal to 8 given this domain. Now let's begin from here. Alright, so now the first graph, you have a f of x equal to negative 3x given the domain like this. Let's begin from here, x and y. Okay, now your domain is smaller than or equal to negative 4, so your borderline is negative 4. So negative 4, not 40, sorry, negative 4. So when x negative 4, this number is going to be negative 4 times with negative 3, it's going to be 12. That's for 1, 12. And then one more number, one more point, so that we can graph this. When x is negative 5, say negative 5 times negative 3 give us 15. That it is. So now let's graph this line first. Negative 4, 12. So you have this one on the negative side. 2, 4, and then 12. 2, 4, 6, 8, 10, 12. Alright. At one point here, make sure it's a solid circle. And then one more line, negative 5. And then 15. This is negative 5 here. 15. This is 12, 14, 15. Somewhere here, 15. This is a 12. And this is 14. And this is 15. After that, we draw connecting this point. Now you have 1. Another line is the f of x, is the f of x equal to x. Now this is starting from 0 and all the way through 3 is the borderline. So I put 0 first. When x 0, y also 0. When x is 3, y also 3. Now let's start graphing. 0, 0 somewhere here. But since this is without the or equal to, you give a solid line. A solid circle, sorry. And then 3, 3. Since this has smaller than or equal to, you have a solid circle. 3, 3 somewhere here. Make it a solid circle like this. Okay, once open circle, because of this one has no or equal to. This one here is solid circle because it has this dash down here representing or equal to 3. After you have this, you just connect the 2 points together. And then another one, f of x equal to 3. Oh, sorry, equal to 8. This one right here, equal to 8. Given that x is greater than 3. Alright, x greater than 3 starting from this direction, and y is 8. So you have it 2, 4, 6, 2, 4, 6, 8. 8 right here, and x starting from 3. So 3 somewhere here. And since this is no equal sign, I mean no dashing like this one, just greater than 3. So you're just using a open circle like this. You're using solid circle like this if it has or equal to like this. But if just plainly greater than like this without or equal to or dashing below it, then you given a solid, open circle like this. After you draw that, then x is greater than 3 all the way through to 3. So no matter how many value of x you want to give, the y always equal to 8. 8 always. So you draw this like this. Sorry for the sound. Okay, now after you're done drawing, identify the domain and the range. Domain and range. And get the domain first, the D. Domain. Right, now domain starting from here is -4 to this direction. So this is the borderline. Look at this graph. So that all the way through to this direction. So it seems like we have x value which is smaller than or equal to -4, and then we have one section out here from this side all the way through to this side. So you have 3 and 3 here connecting all the way through, or you can put or x greater than or not equal to, greater than 0, because of open circle right here, not equal to. So one side for the direction, domain, and for the range. Once we have two set of domain, this set and the other set. Now for the range, let's say, how many do we have here? Now for range, you have one set greater than 12. So you have the f of x is right like this, because in this function is greater than or equal to 12 for this side, 12 and above. And then another section, you have a range 1 is equal to 8. So you have this one, f of x equal to 8. That's one of this one. And then another section, this one right here, you have a f of x in between 0 and 3. Okay, so we have 3 sets of the range. One set for this one above 12, and one set always equal to 8, and another set here in between 0 and 3. Now let's move on. Number 2. Okay, number 2, we do the same thing, graphing the set, each of these set first. Okay, now graphing this set first, f of x equal to 2x plus 2, and for domain, for the point to graph this one, looking at this together, this is x smaller than 6, so I will put 6 as the borderline, -6, sorry. And then another point going to be, let's say, -7. Let's start. When this is -6, so -6 times 2 is -12. -12 plus 2 is -10. That's 1. When this is 7, because this is smaller than -6, so it's going to be a -7. When it's -7, -7 times 2, -14. -14 plus 2, -12. let's grab this. When your x is -6, your y is -10. So -6 first. So well, like -10 first. 2, 4, 6, 8, 10. -10, and y -6 somewhere here. And since this will be an open circle, because this one here no or equal to like this, just only the sign but don't have the dash represent the equal to. And then one more point, 7, -7 is 12. So you have, this is 10 and 12 and -7 somewhere here. I put a dot, a little dot right here. Now you connect the line, the two together. Okay, that's one. And then another function, f of x equal to this one, the x. Let's start from here. -6 is the borderline, x and y. So I will put -6, I will put 2. Alright, so when x is -6, y also -6. When x is 2, y also 2. So -6, -6, and then you got 2 and 2. Let's grab this. So -6, -6. This will be a solid circle. And then you got 2 and 2. Solid circle as well. Now you connect the two together. Okay, now one more. f of x equal to -3 all the way through. So starting from x equal to 2 or greater than 2. So therefore this is 2 right here, and f of x always equal to 3, always -3, sorry. So starting from here on open circle, that for the x 2 and greater than, so all the way through to the positive infinity, and y is always equal to -3. Okay, now when we grab that, let's identify domain and range. Let's get the domain first. Domain. Okay, now for the domain, which is on the x section, it seems like that all the domain extend from all direction to the positive and to the negative. Negative and positive. So therefore the domain is all real numbers. All real numbers. For the range. Okay, for the range, let's see first. Seems like it, which is the f of x. This is gonna be smaller than or equal to this. Let me check first. You have one set. This -10 on this set. So you have this side for the range. So you have this as smaller than or equal to -10, and then the other set is in between -6 and 2. -6 and 2, yes, in between this. Or f of x in between -6 and 2. I think that's it for the range. Now here comes the step functions. Number 3. Okay, for number 3, I've given you the table value of this. Okay. So this side represents the closest, the bigger and smaller integer it represents. For example, if you have 0, when x0 it's close to 0, so it's 0. When it's 1, 0.1 also 0, 0.5 also 0, 0.6 also 0, 0.9 also 0. But when it becomes 1, then it's become 1. But when it's 1.5, still 1. So this sign, that the sign represent. So this 0 right here, this is all the 0 number belong to the 0, or the 1 number here, 1 point belong to 1, and 2. Even 2.9 right here also belong to 2 also. So from here 0 minus 6 means minus 6. When x negative 1, it means 0, still minus 6, all the way through to 0.9, it means 0 also, still minus 6. When it's 1, then 1 minus 5, minus 6 minus 5. When it's 1.5, it's still 1. So that is sign represent, the sign right here. When even 1.9, it's still 1. So 1 minus 6 minus 5. But when it's sum 2, then you got another set of integer. 2 minus 6, you got minus 4. Even 2.9 still count as 2, basing on this sign. So 2.9 is still counting as 2. 2 minus 6 is minus 4. Now, that is the set of integer you need to consider in order for you to graph this function we call a step function, given you this sign right here for you to analyze together. Now let's begin, assuming that you already know how to do this part. Okay, let's start. When it is 0, 6, so it seems like you get from 0 all the way through to 1. But when it reaches to number 1, it jumps to the range become -5. So let me teach you how to graph this. So it seems like you have, when you're 0, -6, okay, 0, x0, y -6, so you're given a solid circle like this, and you can count on the way through here from this side to number 1. When it reach number 1, it jump over to the other set, which is a -5. So to this set, so this set give it a solid circle as well. It means that this has become an open circle, this solid circle. So you can list it all. So 1.5, 1.9 also considered as -5. So all the way through like this, and reach number 2. When it reached number 2, it jumped over to -4. So give this one a solid circle -4. It means this one here going to be open circle like this. Now you can see the story that from that you can continue furthermore to complete all of the steps. So as you can see, one step, two steps. The rest of the step you're counting the same process. So let me finish all of this. Open circle, solid circle, all the way through, open circle, solid circle, all the way through like this, open circle, solid circle, and all the way through like this, open circle again, and then this is solid circle all the way through to open circle, and you also extend this to one side as well. It's gonna be in an open circle, solid circle, open circle to solid circle like this. Okay, that's our step function. Number four, I'll also give you the table function right here. So when it's 0, 0 times 3, 0. 0 plus 2, you got 2. So when x0, y is 2. x0, y is 2. Give this one an open, solid circle like this. At 2 when x0. Now notice that I grid the y 1, 2, 3 by default, but for the x axis, I count 3 of the grid as 1 unit. I did like this basing on this form right here. So before you decide how to grid this one right here, you must find this table value first. When you find this table value, then it will give you a better picture of how to draw the graph. So before you start drawing the graph, make sure you find this table value first. I did this because it seems that the step changing every 1/3 of x value. That's why I do 1, 2, 3 like that. Separate this 1 unit, make it 3 inside it, so that it gives you a perfect step rather than just estimating where to go. So let me repeat, before you draw this graph and given the grid and value like this, make sure you find this table value first, then you will know. And I did like this 1, 2, 3 like this, 3 units or 3 grids to make 1 unit, because look at the table value, it seems that the y value changing every 1/3 of the x value. That's why I did like this, to give a perfect step. Okay, now if you continue furthermore, for example, let me do this, if 0.1, so 0.1, 0.1 you times with 3, and then you plus with 2, it's gonna give you 2.3. 2.3 using this sign, 2.3 it means 2, still 2. You go to 3 also, 0.3 times with 3 and you plus 2 will give you a 2.9. 2.9 by definition of this sign, it's still 2. But when you use number 4, 0.4, so 0.4 times with 3 and you plus with 2, and then it gives you a 3.2. So 3.2 by definition of this sign, it becomes 2. Oh sorry, it becomes 3 because 3.2. So you can see that every 1/3 of x is changing. See 3, 3, and then when you come to 7, it becomes 4. So every 1/3. That's why I'm using 3 of this to make 1 unit. Okay, now let's graph. So 1/3 of this, 0.3, 0.36, and 0.9 or 1. So from all the way through from this to this side, and I give you an open circle on this, and then it becomes 0.4. It jumps. So this is somewhere 0.4, 0.3 together. It jumps over to 3. So y become 3. This becomes 0.4 right here by estimating, and it goes through, all the way through to this size, the 0.6 or 6 point something, you can say, and then give you an open circle as well. And then as you move on further, you raise a little bit higher, it becomes to this number, y becomes 4. So you give a solid circle like this, and then you do the extend it this way, and you open circle like this. Now you already have this one, and you continue to finish the graph. Solid circle, open circle, solid circle, open circle, like this. And you can extend from this direction also. This is going to be a open circle, solid circle, open, solid, open circle, solid circle, open circle, solid circle, and then open circle with a solid circle. Alright, that is done. One more number on the step functions. Okay, and this number also gives us the table value. So I hope you by now you understand this sign. So I will explain you furthermore. When x0, this is -8. -2, 4, 6, sorry, 2, 4, 6, 8, -8 somewhere here. So I'm gonna give a solid circle like this. And we continue all the way through. So it seems like it's changing. I do the same thing like this number 4 a while ago, because as it seems like by this value, the step change every 1/3 of x value. So you can move it, that's why I put it all 3 grids for 1 unit. So you move all the way through to this side, gonna be open circle like this. Now at that, when this open circle, now it become -7. So you move half a step up. So this is gonna be 2, 4, 6, 8, 7 right here. In the middle, a solid circle like this. And you can assume this all the way through here, gonna be open circle right here. Now as you continue furthermore, you can see that when it's 1, it's become 5. So continue your step, you have this open a solid circle and then open circle. Continue one at a time like this. Solid circle, open circle, solid, open, solid circle, open. This is solid circle, open circle like this. Okay, you can also extend this one to this side also. Solid, it's open circle, solid circle, and then open to solid circle like this. Okay, now before we go furthermore, let's try to find domain and range first. Okay, now for the domain, as you can see, it extends to this direction and that direction. So this is all real number, positive or negative, all real numbers. For the range, well, for the range, as you can see, you jump over 1, 2, 3, 4, 5, and so on. So all the range is no decimal number. So the range is positive or negative integer, or you can just say all integers. Integers. The same go with this one here. For the domain, x all real number. And for the range, this is all integer, all integers. Number 5, for x value or domain, this is all real number, all real numbers. For the range, all integers. Okay, now let's grab absolute value function. absolute value function, very easy to graph. First of all, identify the vertex first, because it's going to be a V shape. So the vertex going to be 5, 0. So 5, 0, 2, 4, 5, 0 right here. Okay, that's a vertex. And then you give one more point so that it gives you the direction of the side of the graph. So if you're going to give x, a 1, let's say, not 1, let's say, alright, let's say x1. But let's make it 3. When x is 3, 3 minus when x is 3. So let me put right here. xy. When x is 3, 3 minus 5 is minus 2. Minus 2 within absolute value function become 2. So 3, 2. That's one side of the V shape. Alright. Now since this absolute value function is a perfect V, you do not need to find another point. All you need to do is just counting this grid so that it will make a perfect V shape. So another point going to be here. Now here it is, a perfect V shape. Now for the domain, in this particular case, domain, it extends both directions, to the left and to the right. This is all real numbers for domain, all real numbers. Now for the range, as you can see, it's starting from 0 and upward. So you can say that all for real number is the f of x which is greater than or equal to 0, which means from 0 upward. Let's move on to other numbers. Okay. Number 7, graphing. Still absolute value function. Looking at this one together, as you can see, let's get the vertex first. The vertex is going to be 0, -8. x0, y -8. This by default is 1, so 1, 2, 3, 4, 5, 6, 7, 8. 0, -8, that's 1. And you give x one value. Let's say if I'm going to give x 2. If my x is 2, let me put right here, somewhere here, x and y. If my x is 2, 2 times 2, 4. 4 minus 8 minus 4. So when my x is 2, y is minus 4. 2, 4, somewhere here. So that's one side of the graph. Now since this is a perfect V shape, let's count the number of grids. So going to be one more point right here to make a perfect V shape. Okay, now once you have this, let's get the domain and the range. Now for domain, as you can see, extend both directions, the right and to the left. Therefore, this is going to be all real numbers. And for the range, as you can see, f of x is starting from -8 and above. So greater than or equal to -8. -8 and greater than -8 going to be going up like this. That's for the range. Graphing the last one, number 8. Let's get the vertex first. The vertex is gonna be 4 and 6. 4 and 6. So x4, y6. This is the vertex. 4 and 6. And then I get one more point. X and y. Let's say if you're gonna give x let's say you're gonna give x3. Okay. Now 3 minus 4 minus 1 becomes 1. 1 times 2, 2. 2 plus 6, 8. So x3, y is 8. x3 somewhere here and y is 8. 6, 8. Okay, this is the point. 3, 8. Alright. Now let's draw it. Connect. Now since this is a V shape, perfect V shape, you will have another point somewhere here. And you connect this together. Right now we have already a V shape. Now for the domain should go with both directions. This is all real numbers. For domain, all real numbers. But for the range is f of x that is greater than or equal to, starting from 6 up, so greater than or equal to 6 for this particular number. Alright, so that is the end of our graphing. This time we are going with the writing equations. Alright, now let's start. Okay, so you have f of x right here, and you need to write 3 equal to, it's the piecewise function. You have one line and this direction of the line. Okay, so I'm starting from here. This is 1, 2, 3. So which means y, which means this will be 3 if x greater than or equal to 3. Look at the value right here, starting from 3 and go. Raise 1 on this side. The middle one I put in the middle. This is going to be negative 1, 2, 3, 4. So going to be negative 4 if x, this is going to be starting from negative 3. So going to be smaller than or equal to, because of the solid circle like this, negative 3. Now let's find the one in the middle. Okay, the one in the middle, all you need to do, you must write in y equal to x plus b. Let's find slope first. Slope rise over the run. So you have rise 1 and run 1, 2, 3, 4. So you have y equal to 1 over 4 x plus b. That's your equation. Let me repeat. To get slope rise over the run, you have 1. Okay, for the rise and the run, you have 1, 2, 3, 4. So 1 over 4. Now to get b value, you're using substitution. For example, in number, you can choose one of the point if you want to choose. I'm going to choose this point here. It's going to be 2, 2. So my y is 2. So 1 equal to 4, 1 over 4, and time x also 2 plus b like this. And then I move this one. This is going to be 2 equal to 2 over 4 or 1 over 2 plus b. So 1 over 2 plus b, when you move this, become 2 minus 1 over 2 equal to b like this. So in other words, 2 minus half. So you get 1.5 or 3 over 2. So to write a complete equation, you have 1 over 4x plus 3 over 2, 1.5. If x is in between, this is negative 2, and 2. That's the condition it must give us. So this equation, x in between this 2, negative 2, and 2. Number 10. Now for number 10, f of x equal to, I put this one first. Now I put this first. This is going to be y equal to 1. So I put 1 right here, give condition if x, this is just greater than no or equal to, because this is a so open circle, greater than 3. And this one right here I put down here is going to be 2, 3, 4. It's going to be negative 4, given condition if x is smaller than negative 2. Okay, starting from negative 2, x all the way through. Okay, now this function, the middle one, rise over the run. So again, y equal to x plus b, then you need to write in this form. Slope first, rise over the run, 1, 2, the run also 1, 2. So it seems like you have y equal to just x plus b. Using 1 point to substitute to get the b value. Using right here 0 and 1. So 1x0 plus b, your b equal to 1. So to write the function, you will have x plus 1. If that's the condition, your x value is in between 0 and 2. Okay, that is all for number 10. Now number 9, okay, I missed counting the number. It should be 9, 10, it should be 11, and should be 12. Okay, now using graph to write an absolute value function. Oh, okay, now absolute value function is in the form of y. Let me write the general form first. Y equal to a, x minus h, and then plus k. This is the general form of the function, where h and k representing the vertex, and a will be coefficient. Now let's begin with number 11. Number 11, I will write like y equal to a, x minus h. H and k is the vertex, so it's 1, 0, 0, so minus 0 plus 0. Or in other words, y equal to a x. Ax. Okay, now after that, sorry, a, this one x, like this, sorry. After that, you're using 1 point on the graph to find the value of a. Now I'm going to use this point right here. This point going to be x2, y1. So y1 equal to a, your x is 2. So 1 equal to 2a. It implies that a equal to 1 over 2. So now we have complete function. So this function is f of x equal to 1 over 2 of x, like this, because they don't have the h and the k, because it is 0, 0. Now, number 12. Number 12, the vertex is -3 and -2. So I have y equal to a, x. This is -2, so minus, sorry, not 2, 3, sorry, 1, 2, 3, yeah, 3. So minus -3, and then plus k for the y, which is -2. Let me simplify this. Y equal to a, x plus 3 minus 2. That's what we have. After that, find one more point on the graph so that you can using substitution to solve for a. So I'm going to use this point right here. Okay, the point is x -1, y is 1. So y is 1, so 1 equal to a, x here -1 plus 3 minus 2. So 1 equal to a, I got 2 right here because -1 plus 3, I got 2, and minus 2. I move my 2 to the other side, you're gonna have 3 equal to, this is positive or negative, become positive, plus 1 become 3. 2 times a, I have got 2a. So it implies that a is equal to 3 over 2. Okay, so now I got all the complete of my equation. So f of function is equal to a, which is 3 over 2, and x plus 3, and then minus 2. Plus 3 from here, the vertex, and then minus 2. Okay, that is it for this section.